Hello students. Hello students. Today we are going to study or learning next chapter number system and course of SY computer and for SYIT this is the first chapter first point. Number system define set of values used to represent quantity and the number of values that digit can assume is equal to base of the system. It is also called as radix of the system. For example, decimal system of the base is 10. So every digit can assume 10 values from 0 to 9. The largest value of the digit always 1 less than base. That base is 10, so the values are represent from 0 to 9, that is a less than 1 by base. Largest value digit of digital system is a 9 and each digit position represent different multiple of bases, that is a number have positional importance, so we can implement common rule for all the number system as follow. For general number we have to multiply each of digit by some power of base or radix and the column number of this number assigned to digit placed in the relation with the decimal point. And that column number left of the decimal number start with 0, 1, 2, 3 in diagram, and column number are the right, the decimal number start with the in terms of power -1, -2, -3. There are the various number systems and their bases. For every number system, that is a digital system, that digital system or digital system is known as, this is a in digital system this is a we use the digital signal, and that digital signal works on this digital signal process, or this digital system is processed on a digital signal, so that system is known as a digital system. And in a digital system, this digital signal having the distinct or finite number of values. So there are the different signals in a digital signal, that is a binary signal, octal signal, and hexadecimal and decimal. For every signal having distinct value or finite number of value, and that finite value, if there are the values are 0 and 1, there are the two values, so that signal is a binary signal. If that distinct signal is 0 to 7 represent, there are the 8 values, so distinct values are 8, 0 to 7, so that signal is known as a octal signal. And if that signal having distinct value from 0 to 15, then that signal is known as a hexadecimal number system. If that signal having distinct value 0 to 9, that 0 to 9, so that signal is known as a decimal number system, decimal signal, and that decimal system process the decimal signal, so that system is known as a decimal system. That system, binary system, process the binary signal, so that system is known as a binary signal. So there are the various system and their bases. Binary number system base 2, octal number system base 8, decimal number system is base is a 10, and hexadecimal number system is a 16. And that number system means define set of value used to represent the quantity, and that number of values can be that values that digit can assume is equal to base of the system, that is called as the radix of the system. In this diagram, radix point, that is a radix point is a middle point or base point, and from that base point that a number is represented as a column number, and that column number, the column number is number assigned to the digit place in the relation of the decimal system. Column number of the left side of the system is represented as a form, that is a left hand side as a representative in terms of power 1, 2, 3, and in terms of right, that is represented as -1, -2, -3, and that b is represented as in this base. If base is 2, this 2 raised to 1, 2 raised to 2, 2 raised to 3, and this x is represented the number, that x, and right hand side represented in terms of power negative. There are the different number system. That first is a binary number system. In that binary number system, base has 2, that it has only digit namely 0 and 1, and the weights of the binary number are represent as a, this is a base point middle. From the base point left hand side represent 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, and right hand side represent 2 raised to -1, 2 raised to -2, and that x is a that problem number is, and this 2 is represent base, and that base represent from the radix point as a positive terms, and in terms of powers positive and negative. That first number system is a decimal to binary conversion. In that decimal to binary conversion, there is a decimal number is divided by into its equivalent binary number successively divided by 2 and note the quotient and remainder. The division of quotient of 2 continuously number then longer by divisor, and that binary number is read from MSB to LSB, that is a bottom to top. And in case of if that multiple the decimal number system is in the fraction, that fraction number multiply by 2, and that if that result has 0 before the decimal system, it is recorded and procedure continues depending upon the significant digit. In this first problem, when this conversion decimal to binary number system, decimal to binary, that decimal 25, base after that bracket 10, that number is represented as a decimal, base is represent 10, so this is a decimal. To convert into binary, after that bracket there is a base is to represent, so that conversion is decimal to binary. So this decimal to binary conversion we converted into binary number dividing by 2 and noting the quotient and remainder. That first conversion 25 divided by 2, that is a this conversion you have to see that conversion quotient and remainder here we note, and after that last this 2 is not divided by 1, so this 1 is recorded into this remainder, and we noting that MSB to LSB, MSB to LSB, this number that is 11001, this is a number, that 25, this is a decimal number, 10 base, so this convert into binary, that is 11001, that we noting that MSB to LSB, top bottom to top. After that conversion we, after that bracket we note we write the base is a 2. This conversion is a binary to decimal to binary. Next, if that in case of decimal, that fraction number, this second problem 0.875, after that there is a base 10, this is the fraction number of decimal, this is converted into binary. If that number system in a decimal number there is a fraction number, that fraction number multiply by 2, this 0.875 multiply by 2 and 1.75 this answer. After if result at 0 before this decimal system is recorded, that 0.7 this is recorded, and this 0.75 again divided by 2, and this one is divided here in a remainder. This 0.725 again divided by multiplied by 2, and answer is 1.5. After that point there is a after that 0, that decimal recorded and procedure continues upon number of significant digit required. This 0.5 1 is recorded in this here in the answer or in a remainder. This 0.5 again divided multiplied by 2, that 1.0, and there are we recorded and procedure continues depending upon the number of significant digits required. Number of significant digits are required, and that noted as from LSB to MSB, LSB to MSB. That answer 0.111, that if that decimal number is a fraction number, decimal number is a if a fraction number. In this problem there is one mistake from top to bottom, that is MSB to LSB, top to bottom we noted that answer for the fraction number, and in that 25 divided by 2 in that bottom to top, and if that fraction number we convert into decimal to binary, in that we note the answer from top to bottom, Then another example, that you have to solve. This is the another example. You have to solve these all examples for practices. Next conversion, binary to decimal. In that last point, we convert decimal to binary. Decimal is base 10, that convert into binary. Binary is the base 2. Next conversion, binary to decimal conversion. In that binary to decimal conversion can be converted to into equivalent decimal number by multiplying of bits by their binary weights, and the bits to the left of the decimal are multiplied by powers of positive terms and form terms, that is, and form LSB to MSB, and the bits to the right of the decimal are multiplied by negative powers of 2, that is a 2 raised to minus 1, 2 raised to minus 2. That first example, 11011, this is the binary number, that base is 2, that convert into decimal number system. So in this first 11011, this is the first example. In that first example, that this LSB to MSB, we represent the weighted position. For that first one, there is a 2 raised to 0. 2 is the base, because this is the number system is binary, that convert into decimal number system. This is the 2 raised to 0, 2 raised to 1 for 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. This is the weighted position in terms of power. In terms of power, that is a positive term. If after that there is a 1 point and some number is represented, for that right hand side, that terms are represented in terms of base, that is a negative terms. And in that column number, in diagram that first page, there is a column number, that is a base point. After that base point, there is a x into b raised to 0, x into b raised to 1, x into that, x is represented as this numbers of the binary number, and we calculate that number, and that answer is the, for 11011 is a 27. Second example, in that second example, 0.11011, that convert into binary number is converted into decimal. Then see point, after that point, that number, this is a weighted position, is represented as a right hand side. That right hand side number base is represent in terms of power negative. So first after that point 11011, that first one, this is represent 2 minus 1, 2 raised to minus 2, 2 raised to minus 3, 2 raised to minus 4, 2 raised to minus 5. This is the right hand side of the weighted position, represent in terms of power negative of the base 2. So that converting, and there is the answer 0.842. Next example, that 0.0111, 0.011. This point is a base or radix point. After that radix point, to represent that number or that decimal, convert that number in terms of power, weighted position you have to represent. For this one, this is represented, we convert that 2, base is 2, so this base is a 2 in terms of power. This 2 raised to 0, 2 raised to minus 2, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5 for this number. And after that 0, after that point 001, this is the right hand side. For that right hand side, that powers are represented negative term, and in terms of base is 2, that convert we binary number into decimal. So 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, and this is the calculation, and answer is a 23.125 base 10. This is a conversion of binary to decimal number system, binary to decimal. And for homework, you have to do that 0 to 15 numbers. This is a conversion, 0 to 15. This 0 number base 10, decimal number is converted into binary. This all conversion you have to make the practices. 0 to 15 numbers we have to convert in a binary number, decimal to binary. This is the practice. Next number system is octal number system. Octal number system base is a 2. Sorry, base is a 8. So it represents the values from 0 to 7. Using this digit, we can represent a number. In this number octal system that requires 3 bits are represent. There are the number of bits that represent in the 3 bits. There is a represent the 3 bits. And in that first number system, decimal to octal, that conversion in first, there is a same, only base is change. For decimal to binary, binary is a base, so divide by 2. In this octal number system, base is 8, so that decimal number is divided by 8. Same procedure, only change is that base is a 8. That first example, 24610. Base 10 to convert into octal. Octal number system base is 8, that 246 divided by 8, and we note the quotient and remainder. And in this that answer, that is we read from bottom to top, that is 366. That is the answer of that 246. That conversion 246 decimal to octal. Only change in same, that decimal to binary we divide by 2, because binary number system has base 2, octal number system base 8, so we convert. Same decimal hexadecimal, same explanation in a hexadecimal also we see. If that decimal number system is in a fraction, that convert into octal, then multiply by 8, and after that point you have to note that after that point, this take the number again that multiply, and this significant bits we have to multiply up to 4 up to significant digits or bits, and this is process. This 2 is recording answer. Again this 0.08 multiplied by 8, answer 0.64. So this is not an answer here. 0.64 again multiply by 8, answer 5.12. This 5 is noted here. 0.12 multiply by 8, 0.96. Point is not a 0.9. Sorry, 0 is noted here. 0.96 is again multiplied by 8 and 7 point. Up to 4 to 5 or 2 3 significant digits or bits we have to multiply, and that answer for fraction number you have to record from top to bottom. So answer is 0.2. This is a 20507, base is 8. For fraction number, answer is record from top to bottom, and in this numbers is in first example you have to note the answer from bottom to top. This is the first example for a decimal to octal number system. Next, same octal to binary. That octal number in a binary number system that represent 3 digits, and this represents octal digits that represent each octal digit by 3 binary numbers. 7 is or 1, that number 7. That in that practice there are the 0 to 15 we convert number, that number are represented in a 4 digits, but that in a octal number system 0 to 15 all numbers are represented in a 3 digits, So that first conversion, that next conversion, octal to binary, 777.0.05. This is a octal that convert into binary. Octal number in a 7 is represented in a 3 digits. So that 7 is a 111. That in a practice there is a homework that say that point. That 7 number that represent we convert into binary, 7 divided by and this process, and that answer 011. This represent in a 4 bit. So in a binary that is a 4 bit represent, as well as in a hexadecimal number system this represented in a 4 bit. But in this last 3 digits, these 3 bits are represented in a octal number system, in a octal. So that 7 in a binary is represented as a 3 bits 1 1 1. Base is a 8. So 2 raised to 3 is equal to 8. So in a octal number system, binary number system represent in a 3 digits. In a 3 digits. That's 7 in a binary 4 digits 0 1 1 1. That last one is a B0, B1, B2, B3. This 0 is represent bit is a B3 bit. In a octal number system, only 3 digits, last 3 digits are represented, that B0, B1 and B2. That is 1 1 1. This is the number system represent in a octal. So that 7, that example for the octal to binary, that number system 77705. 7 is represented 1 1 1 because that's this easiest form conversion, that 3 binary digits represent an octal digit system, and in a binary there is the only 3 bits represent, 3 bits. So 7 in a binary 0 1 1 represent, but in a octal to binary when conversion, that represent in a 3 digits, that is 1 1 1. 7 1 1 1 1 1, 0 is 0 0 0 5 1 0 1, and that is a answer, that is a 7 7, that in a sequence you have to write, and that is a conversion octal to binary. Next conversion, binary to octal. In a exactly reverse of the octal to binary, that is a conversion, that binary group digit into 3 digit group. Binary number is given, that group into 3 group, and that number is conversion binary to octal. Binary to octal. That first is octal to binary. Let's see, this is the 10110001.011000101. This is the binary to convert into 8. There is a one base point or radix point, that is a point. After that point, left hand grouping this exactly reverse of the octal to binary conversion, that octal to binary number we represent in a 3 digits binary number, and this binary number group of binary digit in a 3 bits group. So 3 bits group we have to start from the base point or radix point. So 1 0 0, this is the first group, 3 digit in a 3 bits group. Next 1 1 0, that is the next bit. After that is only 1 is represented, so to complete bit we have to add that 0 0. So that 0 0 1, that is represent in a 3 bits or 3 digit bits, that is a binary number represent. So grouping of binary number in a 3 digit bit, and after that here point 0 1 1, this is a one group, 3 bit. Next 0 0 1, this is the next way. After that only one remaining. For complete 1 not 0 1 is only represent, there are 2 bits. To complete bit we have add here 1 0, and that is a 0 1 0. This is the complete bit. So this number is represented in a 3 bit groups, and you have to write for that 3 number, that is first group. This is a 0 0 1, that in a binary, in a octal number system, that binaries represent 1 0 1 1. This is represent 3 0 1 1. In a octal number system, 3 digits represent 1 0 1 1. This is represent 3 0 0 1. This is represent as a 1 number. 0 1 1 0. This is represented as a 2. In a 3 bit represent in a octal number system. Next is a octal to next you have to this practices that convert that numbers. Next, octal to decimal conversion. Octal to decimal conversion same as a binary to decimal. In a binary to decimal, expect that base is a 2, but here only take the base is a 10. All the digits to the left of the decimal have positive powers, while those right have negative powers. That conversion 271. This one is a starting. This is LSB to MSB. 271. This is octal number that convert into decimal. That base is for octal number system is 8. Then in a column number, that is x into b raised to 0, x into b raised to 1, x into b raised to 2. that is a column number, that is after that radix point positive terms and negative terms in terms of powers represent, and that x is a number and b is the base. For every system base is a change. So this base is a 8, so multiply by base. This 1 first is 8 raised to 0, 7 for base is 8 raised to 1, for 2 base is 8 raised to 2. So that x that represent as a number 2 into 8 raised to 2 plus 7 into 8 raised to 1 plus 1 into 8 raised to 0. These powers are represented in terms of power positive. There is a no point, or after that radix there is no another number of the point. So these are the positive terms represent, and that number convert after that calculation 185. That conversion is a octal to decimal conversion, same as a binary to decimal, only base is a change. Only base is a change. Second example, 0.1231, 0.123. This number is represented in terms of power, that is a right hand side, right sides. So that powers are represent for the right hand side numbers are a negative. After that point, in the first example there is a not a base or radix point, that is a directly number is, so that number is represent as a 8 raised to 0 from LSB to MSB, least significant bit to most significant bit, 8 raised to 0, 8 raised to 1, 8 raised to 2, 8 raised to 2. But here there is a base or radix point. After that the numbers are represent, so that number having right number having negative powers, that base for the system is 8. So 8 raised to minus 1, 8 raised to minus 2, for this 2, for this 3, this number is in terms of power is represent 8 raised to minus 3, 8 raised to minus 3. Point, this is x into b. X means here is a 1 into 8 raised to minus 1. This is base in terms of power negative, plus 2 into 8 raised to minus 2, plus 3 into 8 raised to minus 3, plus 1 into 8 raised to minus 4, and we have to calculate that answer 0.66162. That conversion is a octal to decimal number system. Next is hexadecimal number system. For hexadecimal number system, having base is a 16, so that numbers are represent 0 to 15 are as a 0 to 9. In a binary or hexadecimal number system represent same, but in after 10 that number is represent as a character, A, B, C, D, E, F up to 15. In a hexadecimal number system, 10 number is represent A, B, 11 number is represented by B, 12 number is represent C, 13 D, E 14 number, and 15 number is represented as a F in a hexadecimal number system. 0 to 9 same as a binary or hexa, but after that 10 that numbers are represent A, B, C, D, E, F. First conversion, decimal to hex. Decimal to hex number system same as a decimal to binary or decimal to octal, that divide by we 2 and recorded the answer, and that answer is noted from top bottom to top, same. That is a conversion decimal to hexadecimal. In decimal to hexadecimal number system, that is a base is 16, so we divide the by 16 number and record that answer. If that fraction number is given, that fraction number is multiplied by 16 and that answers are noted. At first example 2338, 233, 16 is divided by for 2338, so remainder and quotient is noted. Again 16 is divided by for this number 146, and here is the answer is noted, and 16 again, this 16 is not divided by 9, so this 9 is recorded into answer, and that answer recorded from bottom to top, that is 922, and this is a fraction number. For that fraction number 0.122, this is fraction number. This conversion is a decimal to hexa, so multiplied by 16, and here is a divided by if integer there is a divide, and it will be fraction that is multiplied by 16. For fraction number, answer is noted from top to bottom, so answer is a here is one mistake, answer in a right has 0.1 F3B6, that answer is not for bottom, top to bottom. You have to make the practice these examples. Next number system, hexa to decimal. Hexa to decimal number system conversion, the hex number is multiplied by in terms of power 16. So this digital number left hand side are multiplied by positive powers, and right hand side of decimal number are positive by multiplied by negative powers of 16. That is 2AF 16. That conversion 2AF, that conversion hexa to hexa to decimal. In that conversion, first is F A. This F is represent first LSB number, 2 is MSB. Start LSB to MSB, that powers are we write. For F, this is the first base is 16, and 16 raised to 0, 16 raised to 1, 16 raised to 2. After that, there is no point number or base point, so this start from the only positive numbers for the left hand side in terms of base. So this number calculation 687. Point F27, point F27, that point F27, these are the numbers. After that point, there is a point that numbers are right hand sides are are multiplied by negative powers of 16, or base is a 16. So for F, this is a 16 raised to minus 1. For 2, 16 raised to minus 2, 7, 16 raised to minus 3. In that column number that represent one radix point, that x into b raised to 0, x into b raised to 1, x into b raised to 2, left hand side, and right hand side terms are represented as a negative term, and that x is a number, that is a f or anything 1, 2, 3. B is a represent for every number system as a base. For binary 2 number base. For octal represent 8, and for hexa that base is a 16. So here is a 16 raised to minus 1, 16 raised to minus 2, 16 raised to minus. These for F27, these are the represent as a right hand side of the decimal are multiplied by negative powers of 16. And that answer is calculated as a, check that by Calci. You have to make that practice. Next example. Next conversion, hex to binary. In that hex to binary number system, hexa number is a group of 4 binary digits. 4 binary digits. That is a one example. That number is given that represent only 4 digits. FEA. F means represent in a hexa 15. E means in a hexa represent as a 14 number. And A number is represented in a hexa as a 10. And these numbers are represented in a binary digits is a group of 4 binary digits. 4 binary digits. In that first point, there is a one practices 0 to 15 number we convert, that we see. That 15. That 15 is convert decimal to binary. Decimal to binary, that number is represent 15 as a 111. 111 in a 4 digits. In a 4 digits. In a 4 digit. Same for that all numbers you have to see. And in that example, that conversion you have to write that hexa to decimal number, hexa to binary number system that represent 4 digits. That hexa to binary that represent 4 binary digits. So 15 is represented as in a binary as a 111, as a 11. But in a hexa number system, F is represented as a 15. 15 is represented as a F. So this F, E, A. F means 15, E means 14, A means 10. That in a binary 0 to 9 in a binary or hexa represent same. But after that hexa number system represent as a 15 as a F number, or 10 as a B, C, D, E, F, 10 to 15. So this 15 is a represent and a 4 binary digits. So 111, 14, 111. But in octal, that same 15 number or 10 number represent in a 0 to that represent in a 3 digits, because that base has a 8. 2 raised to 3 is equal to 8. 2 raised to 4 is equal to 16. So that in a hexadecimal number system, binary number is represented in a 4 digits. So hexa to binary conversion as a hex number is a group of 4 binary digits. So this total answer for FEA 111100, that 11111 11101010. This is the base 2, that is a conversion from hexa to binary. Second example, A is represented 10 to 5. That for a 10 number, binary number is a 100, 2 is a 0010, 5 number is represented as a binary 010, and that is grouping of all these numbers as a 0.100, represent 4 digits, 4 100 0001 010 as a 4 digit. In octal, that is represent only 3 digits. Next conversion is a binary to hex. That binary number is given, and that binary number is a group of 4 bits. Same conversion that we study, binary to octal, that is a grouping of 3 numbers, and here there is a grouping of 4 bits. There is a 110011 0.01101. After that, this is a point. From point we have to start that grouping. 011, this 0110, this is a 4 bits. Next number is 011, 011, that number is not after that one. So for complete bit we add that number as a 0. So we complete bit as a 4 bit. After that point 0110, this is a 4 bits group of 4 bits. Next 10, there are the only remaining 2 numbers, but that not represent 4 bits. So we have to add to complete bit 00. So complete bit, and that number is a group of 4 bits, and that number is represent 66.68 8. Next conversion is a hexa to octal. Hexa to octal conversion. First, to convert hexa to octal, we represent hex number into binary. First hexa number is represent binary, but hexa to binary number represent into 4 bits, and that conversion, first hexa to octal, that binary number, hex number is converted first binary, that represent each digit by 4 digit, and combine then again group of 3 bit, because octal number is represent in a 3 bits. That first conversion, 4CE, 4 is represent in a binary number as a 4 digits 011, 4 bits. 12, C means 12 in a hexa, that C is represent 12. So for 12, 1100, that is a binary number in a 4 bits. Again 14 is a represent, E is represent as 14. So 14 number binary is a 111, that is a hex to octal convert octal to binary, hex to binary first, and binary number combine groups of 3 bits. Combine group of 3 bits. I have to combine that start from here. That 011 from LSB to ML, 011. This 100. Then 100. This is 3. 010. This is 2, and that number is a 23. First, this is a hexa. This hexa number is represented in a binary 4 digits, and for 4 digits we have to group in a 3 bit. Group of 3 bits. This number binary is group of 3 bits. 011. This is a first 3 bits group. 011 100. This is the 3 bit group. Next 110. This is the next group. 010. This is the next bit. This is the conversion of hexa to octal. Next, that practices you have to take that another example, and same number system, that is a octal to hex conversion. Octal to hex conversion, or octal to hex conversion, that this exactly reverse of hex to octal, that in exactly reverse, that first we convert octal to binary, and octal to binary number is represent 3 bits, and that 3 bits group is a convert into 4 bits. That is conversion is a octal to hex. This is a, see that last conversion, a octal to hex. This is exactly reverse of hex to octal. First we convert octal to binary, group of 3 bits, and then binary number, this converting of octal to binary number, group of 4 bits, that conversion is a hex. That example 371. 371. 1 is represented as a, in a hexa number system, represent 4 bits as a 0001. But that same number 1 is a represent in octal number system 3 bits, that is a 001. 7 number is a represent in a hexadecimal number 4 bits, that is a 0111. But that 7 number is a represent in a octal number system bits by 3 bits, that is 111. 3 number is a represent in a octal number system as a 011, but in a hexadecimal number system that represent 4 bits, that is a 0011. 0011. But that same 3 number is represent in octal number system as a 3 bits, 011. So you have to convert 3711, that conversion octal to binary first, that is a 3 bits, and after that this number is a group of 4 bits. So 1001, this is a first group, 4-bit group. 1111, this is the first 4 bit. Only 0 is represented, so add the 3 zeros to complete 4 bits. So that answer is 0159, but that 15 is represented and hexa is a F, so answer is a 0F916. Same, only change in hexa to octal, that hexa number is represented in first convert in a binary as a 4 bits, and that binary number is a group of 3 bits, that conversion is a hexa to octal, and octal to hexa, octal to binary first convert in a 3 bits represent that binary number, and 3 bits represent as a group of 4 bits, that conversion is a octal to hexa. This is the conversion of all number system. You have to solve this all number system for practices, and all examples are given, and you have to take the calci and make the calculations. If any query or anything doubt in this point, call me or ask that doubts for this all number system. This is the point cover this is the point of first chapter of SY computer number system, and this is the point of first chapter, first point of SY IT, and this number system is a very important, and next point is depends on this all number system. So make the practices for the this different examples. Thank you for watching this video.